Hello everyone, welcome back. Let's talk about another easy problem on Leetcode today. Delete characters to make fancy string. Leetcode 1957. In this problem, we are given a string S and we have to delete the minimum possible number of characters from S to make it fancy and then return the final string after the deletion. It can be shown that the answer will always be unique. A fancy string is a string where no three consecutive characters are equal or same. Then in example 1, for the given string, we will delete one of the three consecutive E's and then we will get Leetcode as our output, and that will be the fancy string because now there are no three consecutive characters that are equal. Similarly, in example 2, for the given string, to make the string fancy, first we have to remove one of the three consecutive A's and then we still have four consecutive A's, so we will again get rid of two A's so that now we have only two consecutive A's. And finally, we will return the string A with no three consecutive equal characters. So now this will be our fancy string. Now in terms of solution, we need to eliminate the characters from the input string to ensure that there are no three consecutive characters that are same. But as the strings in Java are immutable, we cannot modify the string directly. Instead, we can use a mutable string like string builder to construct the result string by adding characters one by one. Now we can traverse the input string, and when we are adding the character to the result string, we need to perform a check that we do not have three consecutive identical characters in the result string. One way can be that we append this character from the input string only if the last two characters in the result string and the current character are not the same. This ensures that we do not end up with three consecutive identical characters in the result string. And finally, we convert this result string back to the regular string. For example, for the input string in example 2, first character we see is A and our result is empty, so we append it to the result. Then we see A again, and again our result length is less than or equal to 2, so we can't have three consecutive letters, so we again append A to the result. Then the third character is again A, and now our result is big enough to have two characters, so we can just make a check on those last two characters to check if they are same, and in this case they are, so we will skip adding this A to the result. Then we see B and the last character in the result is A, so these two characters are not same, so we can append B to the result string. Then we again see A and it is not same as last character in result, that is B, so we will add it to the result. Again we see another A and it is same as last character in the result, but it is different from second last character in the result, so we will again add A to the result. Now when we see the third consecutive A, we can make the check on these two A's, they are actually equal, so we will not add it to the result. Then we see the last A and that is again equal to last two A's in the result string, so we will again skip adding this A. So now we are done with the input string, and finally our output will be AA. Now let's jump into the code part. First, let's initialize an empty string builder to store the result. Now we can loop on the input string character by character and check if last two characters in the answer are same as current character. For that, answer list should at least be of size 2. Then we will continue and skip adding the current character to the output string. Otherwise, we will append the character to the result. And finally, we are done with the loop. So we will convert this string builder back to string. Now let's submit this code. Cool. In terms of time complexity, it will be O of n, where n is the length of the string, because we are going through each character in the string only once. And in terms of space complexity, also it will be O of n, because we are creating this answer string builder to store the result and finally returning the fancy string. But now, suppose the interviewer says, instead of not allowing three consecutive characters, we should not allow k consecutive characters. In such a case, having a hard-coded check will result in the loop up to k. Here we were lucky that k is only 3, so instead of checking for last two characters in the answer, now we will run the loop on the last k characters, and this will result in the time complexity of O of n into k. So to write a more scalable code, we can keep a count of how many times the current character has appeared consecutively so far. This count let us decide if the next character should be added or skipped. So again we will build the result incrementally, that is character by character, and whenever we see the current character is same as the previous character, we will increment the count, and whenever the count of the character is less than 3, we will append it to the result. But if we encounter a new character, that is the character different from the previous one, we will reset the count to 1, as there is no longer a risk of exceeding two consecutive characters. Again, For the given string in example 2, we will see the first character A and the count for it will be 1, which is less than 3. So we will add it to the result. Then we see A again. So now the count becomes 2. And because 2 is still less than 3, so we will again add it to the result. Now we see A again. So we will increment the counter to 3. But because we can't have 3 consecutive characters, we will not append it to the result. And then the next character there is B. So we will reset the count to 1 and append B to the result. Then we see A. So again that's a new character. So we will reset the counter to 1 and append A to the result. Then we see A again. So we increment the counter to 2 and append A to the result again. Then we see A. Now the counter becomes 3. And because we can't have 3 consecutive A's, we will skip adding A to the result. Then we again see the last A, and this time again the counter becomes 4, and because we can't have more than 3 consecutive characters, we will again not append A to the result, and finally our result string will be AABA. Now let's jump into the code part. We can reuse the answer from the previous solution and initialize the counter to 1 and add the corresponding first character to the answer string. Now we can start the loop from second character to the end of the string. And for each character, we will check if it matches with the previous character. If yes, then we will increment the count by 1. And now if count is less than 3, we will add the current character to the answer because so far this character would have appeared at most twice. But if the count is more than equal to 3, we will skip adding this character to the result. Otherwise, if the character is different from the previous character, then we will reset the count to 1 because now we are dealing with a new character and append this character to the answer. Finally, we are done with this loop and now we can return this fancy string. Now let's submit this code. Awesome. In terms of time complexity, it is again O of n because we are going through each character in the string only once. But the runtime has now improved because now we take the decision based on the counter instead of looking at last 2 or last k characters in the result string. And space complexity also stays O of n because first we are storing the result in a string builder and then returning the fancy string. So that's all for this video. I hope this video was useful to you. If it was, please give it a thumbs up and share it with others who might benefit from it. If you haven't subscribed the channel yet, make sure to hit the subscribe button and turn on the notification bell so that you never miss an update. Your support helps me create more content like this. If you have any questions or suggestions, feel free to leave them in the comments below. Thanks for watching and see you in the next one.